Our solar system is a place of staggering extremes, a cosmic neighborhood filled with worlds of unimaginable beauty and honestly, terrifying hostility. Consider Mercury, the smallest of the planets, a tiny rocky sphere dancing closest to our star. It is a world defined by its proximity to the sun. On its day side, the surface is an inferno, a landscape baked under a relentless star 47 million kilometers away. Temperatures here can soar to a blistering 430 degrees Celsius, hot enough to melt lead and tin with ease. It's a vision of hell, a place where no spacecraft could long survive the onslaught of unfiltered solar radiation, a testament to the raw, untamable power of a star. Yet this is only half the story of this enigmatic little world. Spin Mercury around, and you find a completely different reality, a place of profound and absolute cold. The night side is plunged into a darkness that is almost eternal, and the temperatures plummet to a staggering minus 180 degrees Celsius. This is a cold so deep, so penetrating it would freeze carbon dioxide straight out of the air, if Mercury had any significant atmosphere to speak of. The contrast is almost beyond comprehension, a single world that contains both the searing heat of a furnace and the bone-shattering chill of deep space. It is a planet of two faces, one of fire and one of ice. Between these two brutal extremes, however, lies a region of profound possibility. It is a narrow, shifting band that encircles the planet, a place where day meets night. This area, known as the Terminator Line, or more poetically, the Twilight Zone, is where the sun is perpetually rising or setting. It's a place where the light is gentle, where the sun hangs low on the horizon, casting long, dramatic shadows across the cratered surface. Here the ferocious heat has not yet taken hold and the deep freeze of the night is yet to descend. It is a place of moderation, a sliver of temperate calm on an otherwise unforgiving planet. This Twilight Zone isn't a fixed location, it crawls slowly, almost imperceptibly across the planet's face. Mercury spins on its axis with an extraordinary slowness, meaning this gentle region moves at a crawl. Imagine a permanent planetary-wide sunset, a golden hour that lasts for weeks on end. It's within this slender, ever-moving band that the most intriguing questions about Mercury arise. Could this zone, caught between fire and ice, be a place where the conditions are not too hot, not too cold, but perhaps just right? This simple question opens up a universe of speculation and wonder about the possibilities for life in the most unexpected of places. So, why does this Twilight Zone possess such remarkably different temperatures compared to the rest of the planet? The answer lies in two key factors: Mercury's lack of a significant atmosphere and its incredibly slow rotation. On Earth, our thick blanket of air acts like a global heating and cooling system. The atmosphere traps heat and distributes it around the planet, which is why our night side doesn't instantly freeze and our day side doesn't boil. Winds carry warmth from the equator to the poles, moderating temperatures and preventing the wild extremes that we see on other worlds. It's a dynamic, circulating system that makes our planet so uniquely habitable. Mercury, however, has no such luxury. Its atmosphere is so thin it's technically referred to as an exosphere, a fragile collection of atoms blasted from the surface by solar wind and micrometeoroids. This means there is nothing to trap the sun's heat and nothing to spread it around. Where the sun shines, the ground absorbs the full, brutal force of its energy and becomes incredibly hot. Where the sun does not shine, that same energy radiates away into the blackness of space almost instantly, leaving the surface to plunge into a deep and profound freeze. There is no atmospheric blanket to tuck the planet in at night. This is where the Terminator Line becomes so special. In this zone, the sun is always low on the horizon, perpetually rising or setting. The sunlight that reaches this area strikes the surface at a very shallow, oblique angle. Think about the difference between the sun at midday and the sun at sunset here on Earth. At midday, it's directly overhead and feels intense. At sunset, its rays are spread out over a much larger area, and the light feels gentler, the heat far less fierce. The same principle applies on Mercury, but on a much grander scale. The angled sunlight delivers far less energy per square meter, resulting in much milder surface temperatures. Therefore, the Twilight Zone is not heated by a different mechanism, it is simply receiving a less concentrated dose of the sun's immense power. The energy is diluted, spread thin across the landscape, creating a region where the temperature might hover in a range that is far more manageable. While the day side roasts and the night side freezes, this narrow strip offers a potential sanctuary. It's a place where the raw physics of light and shadow create an environment that is, against all odds, surprisingly temperate and stable. A stark contrast to the violent conditions that define the rest of this tiny sun-scorched world. This brings us to one of the most exciting ideas in planetary science, the Goldilocks principle. We often talk about the Goldilocks zone in the context of an entire solar system, the orbital path where a planet is not too close to its star and not too far away, allowing liquid water to exist on its surface. Earth sits perfectly within our sun's Goldilocks zone. Venus is too hot, Mars is too cold, but Earth is just right. But what if a Goldilocks zone could exist not just in a region of space but on the surface of a single planet itself? This is the tantalizing possibility that Mercury's Twilight Zone presents. On Mercury, the planet as a whole is far too close to the sun to be considered habitable in the traditional sense. It's a world that lies deep within the too hot region. However, the Terminator Line acts as a kind of micro-habitat, a planetary niche where the conditions might just be right. Here, in this band of perpetual dawn or dusk, the temperatures could potentially be stable enough to allow for the one ingredient we believe is essential for life as we know it: liquid water. While the day side would boil it away instantly and the night side would freeze it solid, the Twilight Zone might offer a haven. We already have compelling evidence that water ice exists on Mercury. It's found hiding in the one place you might expect it on such a hot planet, in the permanent shadows of deep craters near the poles. In these locations, the crater floors have not seen a single ray of sunlight for billions of years, creating cold traps that are even chillier than the planet's night side. This discovery proves that water, a key component for life, was delivered to Mercury likely by comets or asteroids, and has managed to survive. If this ice were to be exposed to the gentler temperatures of the nearby Terminator line, it could potentially melt and form liquid water. Of course, habitability requires more than just the right temperature and the presence of water. Life needs a stable environment, a source of energy, and protection from harmful radiation. Mercury's surface is bombarded by intense solar winds and cosmic rays, and its lack of a substantial atmosphere offers little to no shielding. Any life would likely have to exist beneath the surface, protected by layers of rock and regolith. But the very idea that a sliver of this hostile world could harbor the fundamental conditions for life forces us to broaden our definition of what a habitable environment might look like, pushing the boundaries of our cosmic imagination. So, what would it be like to stand in this Twilight Zone? It would be a truly surreal experience, governed by Mercury's peculiar and leisurely rotation. A single day on Mercury, the time it takes for the sun to return to the same position in the sky, lasts for 176 Earth days. That's nearly half an Earth year. This is because the planet rotates on its axis incredibly slowly. It spins around just once every 59 Earth days, while it orbits the sun in only 88 Earth days. This strange 3-to-2 spin-orbit resonance means that the sun's apparent movement across the sky is exceptionally slow, a cosmic crawl. This sluggish pace is precisely what makes the idea of a mobile habitat so appealing. The Terminator line, this band of gentle temperatures, creeps across the surface at a leisurely speed of just over 2 kilometers per hour. That's roughly the pace of a slow walk. In theory, a future human outpost or even a robotic one could be built on wheels. It could constantly trundle along, forever chasing the sunset or running from the dawn. This mobile base would keep itself permanently within the temperate Twilight Zone, avoiding both the lethal heat of the day and the extreme cold of the night. Imagine waking up each morning to the same view: a huge sun, 2.5 times larger than it appears from Earth, forever hanging on the horizon. The landscape would be stark and beautiful, a gray, cratered desert under a sky of perpetual twilight. Long, sharp shadows would stretch for kilometers from every crater rim and hill, creating a scene of dramatic high-contrast beauty. There would be no blue sky, only the blackness of space dotted with stars that you could see even with the sun in view, as there's no atmosphere to scatter the sunlight and wash them out. It would be a silent, still, and profoundly alien existence. Would you want to visit? To live in a rolling city that forever chases the light, a permanent resident of the most exclusive neighborhood in the solar system? It's a compelling thought. And as a final surprising fact to ponder, despite being the closest planet to the sun, Mercury is not the hottest. That title belongs to Venus, whose thick, toxic atmosphere has created a runaway greenhouse effect, making its surface hotter than even Mercury's sun-baked dayside. It's a wonderful reminder that in our solar system the rules are often more complex and fascinating than they first appear.